Welcome back to our series, Fundamentals of AI. Today, we're going to break down one of the most intuitive ideas in all of machine learning. Seriously, it's a concept you already use every single day, probably without even realizing it. All right, let's start with a really simple visual puzzle. So on the screen, you've got two groups of shapes, right? Some are blue, some are green. Now, what happens when this new star-shaped item just pops up right in the middle? The question is simple. Where does it belong? I'm willing to bet your brain solved this almost instantly. You look at the star, you see the clusters, and you instinctively know which group it's closer to. And that simple, very human gut feeling, well, that's the absolute key to what we're talking about today. So that intuitive idea, that simple question of what's it closest to, believe it or not, that's the foundation for one of the simplest and honestly one of the most powerful classification methods in all of machine learning. And the solution is, well, it's just as simple as our intuition suggested. All you do is find the single existing data point, the one that's already in our training data, that is the most similar or nearest to our new item. And in this case, yeah, it's pretty clearly one of the green dots. And this right here, this perfectly illustrates the core idea. Once you've found that nearest neighbor, the new item just copies its label. The star's closest friend was green, so guess what? The star becomes green. It is literally that straightforward. Okay, so we've got this super simple intuition. How do we turn that into something a computer can actually use? A formal algorithm? Well, this is where we get to the heart of the nearest neighbor classifier. So this formal algorithm, it's called the Nearest Neighbor Classifier, and it works on just one super simple rule. You give it a new item, it scans through all the data it's already been trained on, finds the single closest match, and just assigns the new item the same exact label. It's really less about crazy complex math and more about a simple search for its nearest digital neighbor. But wait a minute. This elegant simplicity kind of hides a surprisingly tricky question. It's one we absolutely have to answer before we can use this for real. And that question is, what do we actually mean by nearest? Yeah, defining nearest isn't always as simple as, just pulling out a ruler. The way we measure the distance, or the similarity between two things, really has to be tailored to the kind of data we're dealing with. For example, if you have points on a graph, like patient data based on age and blood sugar level, we can just use the standard geometric distance. You might have heard of it. It's called Euclidean distance. But what about something way more complex, like images of handwritten numbers? You can't use a ruler for that. In that case, we might need a totally different method, like comparing the images pixel by pixel to see how many of them match up. The point is, the metric has to fit the data. Okay, so this brings us to a huge real-world application of this whole idea, and it's something you almost certainly interact with every single day: recommendation engines, on platforms like Netflix, Spotify, or Amazon. See, these engines are often powered by a really simple but profound idea. Users who acted similarly in the past are likely to act similarly in the future. This is the core principle behind a technique called collaborative filtering, and as you can probably guess, it's a direct extension of our whole nearest neighbor concept. So what exactly is collaborative filtering? Well, it's kind of what it sounds like. It uses the collaborative data, the behavior, from millions of other users to filter the world of content down to just the stuff you'll probably love. Let's walk through an example. Imagine you're a huge fan of 80s disco, and a brand new song from that era just dropped. Okay, here's the cool part. The system doesn't even need to know anything about the song itself. Not the artist, not the lyrics, nothing. Instead, it just finds your nearest neighbors. In this case, other users who also listen to a ton of 80s disco. Then it sees, hey, these people are all loving this new track. And based on that, it predicts that you'll probably love it too. And bam, it pops right up at the top of your recommendations. Now, this works fine with a small group of users, but just think about the sheer scale of online services. We're talking about data from millions of users. With that much data, the system can find tons of people whose past behavior is almost identical to yours, and that's what makes these predictions so scarily accurate. But there's a flip side to all this. There's a potential downside to an algorithm that's designed only to show you things it thinks you'll like. This powerful personalization can lead to a phenomenon you've probably heard of before: the filter bubble. What happens is these recommendations can become a kind of self-fulfilling prophecy. Think about it. You're more likely to click on something the system recommends, right? And when you do that, you're just reinforcing the system's belief that you like that kind of content.
This creates this powerful feedback loop that over time can actually start to isolate you.
So when a system only shows you news or media or products that it thinks you'll like, it ends up creating this bubble around you. Inside the bubble, your own beliefs get constantly reinforced, and you're rarely, if ever, exposed to challenging, different, or alternative ideas that exist just outside of it. And this brings us to a really crucial question to think about. I mean, are filter bubbles automatically a bad thing? After all, the system is just giving you more of what you've shown you already like. So what could possibly be the harm in that? That's something I'll leave you to chew on until next time.